Okay, so as in the last video we have discussed about the physical quantities, the base or the fundamental quantities, drive quantities, and the additional quantities which were supplementary quantities. In today's video we are going with dimensional analysis. So let me write the definition of dimensional analysis first, then I'll be giving you guys the example too. So dimensional analysis, basically those physical quantities in terms of it can be represented in power. Alright, these are just those physical quantities in terms of which it can be represented in power. So let me write this definition here. Okay, those physical quantities in terms of which it can be represented in powers. Alright, these are nothing but these are those physical quantities in terms of which it can be represented in power. Okay, so let's take an example of speed. We know that what is speed? Speed is the distance traveled by a body in interval of time. Alright, so distance upon time, which means s per unit t. Alright, so the you know what, distance is same as length. Alright, so let's write it as a length upon time, L upon t. Alright, so now let's write the dimensional formula of this. L would be remain on its position, while when t will go up it will get the minus sign, minus power, which means t inverse. T is in the denominator. So this is basically dimensional formula. LT inverse is the dimensional formula of speed, alright, which is distance upon time. Now let's go with dimensional variables. What are dimensional variables? Dimensional variable basically those physical quantities which are variables and yet they have a dimensions too. So that is basically known as dimensional variable. Let's write the definition of dimensional variable here. We have those physical quantities which are variables and yet have a dimensions. Those physical quantities which are variable and yet they have dimensions, those are basically known as what? They are known as dimensional variables. Let's write that now. These are known as dimensional variables. Let's write this here. Dimensional variables. Dimensional variables, those physical quantities which are variables and yet they have dimensions. Now let's go with three basic physical quantities, as you all are known about that: length, mass and time. Basic quantities. Length, mass and time. Length, mass and time. Alright, length, mass and time. We know that the unit of length is what? It is meter. Wait, let me write that too. It is meter. The unit of mass is kilogram and the unit of time is second. Now let's write how they will be represented in the dimensional formula. The length will be represented by capital L, the mass will be represented by capital M, and whereas the time will be represented with capital T. Alright. So now let's go with some dimensions. As I told you what are dimensional analysis, now let's go with some dimensions. For example, the dimensional formula of area of sheet, area of circle, volume, and speed, acceleration, everything. Let's go with that. Okay, so we have area of sheet. Wait, let me write that. Area of sheet, and the formula of that is length into width. Length dot width, which means length into width, is equal to, which means the unit of length is meter and the unit of width is meter as well. So mm, instead of writing mm, I can also write m square, which means m square. Alright, so now we need to write the dimensional formula of area of sheet. Alright, we know that the length would be represented by capital L. Alright, so let's write that. Wait, let me use the marker now. Capital L, and there is a square on the meter. Alright, which means it will have a square as well. And we need to close this. It basically represents the dimensions. Alright, so this is the dimensional formula of area of sheet. Area of sheet, the formula is length into width, and then it is equal to, you know what, the unit is meter, meter same, and then it is meter square, and then we have L, which is the representation of length, and square on the top of it, just because there is length into width and they both have same units. So let's go with area of circle now. Let's go with area of circle is equal to pi r square. Pi r square. Alright. Now an important thing to be noted here is what? Pi is a dimensionless. It has not any type of dimension. So we have to neglect this pi here. We need to neglect all the things which are dimensionless in the dimensional analysis. Alright, so pi is a dimensionless here. We need to neglect this here. So r square, which means you know what, the radius. The radius has the unit meter as well. So meter square, and the dimensional formula of this would be again L square. Alright, so the dimensional formula of area of sheet is same as the area of circle. The dimensional formula of area of sheet is same as the area of circle. L square, L square. Now let's go with volume. Alright, let me write that here. Volume of cube. The formula of volume of cube is length into width into height, which means they all have unit of meter. So which means it has meter cube. Meter cube. So the dimensional formula of this would be what? It would be L cube. L cube. L cube is the dimensional formula of volume of cube. Now let's go with the same you know what, dimensional formula, what it is same to. Now let's take an example of volume of sphere. Volume of sphere is equal to, you know what, the formula of volume of sphere is 4 by 3 pi r cube. Pi r cube. Alright, so what it would be? Let's see. 4 upon 3 is a constant, so it is dimensionless. We need to neglect this here, as I initially told you. Pi is a dimensionless as well. It is a constant. So 4 upon 3 pi these both are the constant and they don't have any dimension, so we need to neglect here in the dimensional analysis. Now what is remaining here? Only r power cube, which means radius cube, and we know that radius is the unit of meter, which means meter cube. And then the dimensional formula of this would be what? It would be again L cube. L cube. So the dimensional formula of volume of sphere is same as the volume of cube. The dimensional formula of volume of cube is same as the volume of sphere. Alright. Now let's go with the speed. What would be the dimensional formula of speed? Let's write this here. Okay, so we have now speed, and we know that what's the formula of speed? It is distance upon time, and distance is basically represented by s over t, which means time. So now what we have, the dimensional formula of speed. Wait, let's write the unit of this first. So we know that the distance is same as length, and length has the unit of meter. So it is meter, and time has the unit of second. So it is meter per second. Now what would be the dimensional formula of this? So distance, as I initially told you, it is represented by length basically, and length is represented by capital L over, we have, you know what now, t, you know what, second. Now it is basically time, and time is represented by itself t. Now if I do take this t up, what it would be? Wait, let's write the dimensional formula now. So the dimensional formula of this would be L, and t, when t will go up, it would have minus power 1, alright, which means L t inverse is the dimensional formula of speed. Now we have another physical quantity as well whose dimensional formula is same as speed, and that is velocity. Velocity has the same dimensional formula as speed. Let's write the dimensional formula of speed now. Okay, so velocity, we know that what is velocity? Velocity is basically displacement over time. Displacement is represented by d, and time is represented by t. What's the unit of displacement? Again it is meter, and over time has a unit of second. Let's write the dimensional formula of velocity now. So we know that distance is same as length, so length is represented by capital L over time is represented by capital T. When if I do take t this up, so we need to take the minus power of t, alright, L t inverse. So this is basically the dimensional formula of velocity. So as you can see, velocity has the same dimensional formula as speed, alright. So now let's go with acceleration. Let's go with acceleration. Wait, let me write here. Acceleration. The acceleration formula is what? It is basically velocity upon time, v over t. And we know that what is velocity? It is basically meter per second, which means it is you know what, distance upon time. So let's write distance over time upon time, which means multiply by 1 over t. 1 over t. What would be the dimensional formula of velocity? Wait. So it would be basically, you know what, velocity over there is tt. So t into t is what? It is t square. T square, which means time square. So you can write it as you know what, t square. It is fine. Let's write now. It's not velocity. It's fine, v upon t. So let's write the dimensional formula. As we have taken the dimensional formula of V, what it is? It is basically L T inverse. Let's write that. T inverse, and we have an other T as well in the denominator. So here we need to multiply this T inverse. Now as you can see, bases are here being multiplying, so we need to add the powers. So L T minus minus plus, but sign would be of minus. 1 is 2. So basically this is the dimensional formula of acceleration. L T squared, that is inverse, alright. L T power minus 2, and this is the dimensional formula of acceleration. Okay, so this was all for today. In the next video we'll be going with dimensional analysis applications.